the Charlies have a demand, they're either willing to have a demand of 1, 1, or a demand of 0, 0, right? And the Sonias are willing to either have a demand of 1, 0, or of 0, 1, right? At those prices, they actually have two things they demand. They don't have one thing they demand. They have these sort of two different things they're happy with. So the two different aggregate demands in the economy then are going to be 2, 1, or 0, 1. Right?
Why is that?
Because we just add up these columns, right? So like you could have, well, I mean, you could do other ones too. You could add these two together. You could, you can choose any pair. But like, two aggregate demands that could occur are 2, 1 and 0, 1. Yeah.
Oh, why do we have the demand 1, 1? Because isn't it $1 and he's only willing to pay 50 cents for the bundle?
He was willing to pay $1 for the bundle.
Oh, okay, sorry.
Yeah. Okay. So, in fact, all of the aggregate demand bundles that are possible, if you do all the combinations, are these ones. All those could occur. So, the basic point is if you were to draw all these out, right? So we could draw all the points out. We know that the endowment is 1, 1, and the equilibrium is where the demand equals that endowment, right? But we now know that this point is possible, this point is possible, this point is possible, and this point is possible. So basically there's a bunch of demand things which are surrounding the equilibrium, but none of them are actually at the equilibrium, right? And so this is what we call the aggregate supply being in the convex hull of aggregate demand. So that means that there are two different points in aggregate demand which are on either side of the quantity that's available in the market, right? And so what basically happens is there comes to be more and more people, is that because they can, now that you have more people, you can do mixtures where some people are doing one thing and some people are doing the other. You start being able, rather than just getting these points that are on the outside, you can maybe get that point as well, and that point, and that point. Because, if 1/4 of the people do this and another quarter of the people do that, then you can get any mixture of these things. And eventually that fills in the whole space in between these 4 points. And anything in there would be in the demand, and including the endowment. And so you get an equilibrium.
So it's the diamond shape between all the points.
Yeah. So basically, this idea works in this continuum economy, but it also works in a large finite economy. Maybe not perfectly. So in a large finite economy, there might be a few points in the diamond that aren't very close to anything that gets filled in, right? You're going to be filling in a bunch of points, and they might not fill in everything, and you might just miss, but you won't miss by very much. And so there won't be very much excess demand or excess supply at some price. And in fact, if you have an even number of people and an even number of goods, if you multiply the economy by any even number, you always get an exact equilibrium. And if you multiply it by an odd number, at most you have you're one off from getting an equilibrium. So in this sense, you can say that 0.5 is an approximate equilibrium in the economy. Because basically, when you're at that point, in some sense, the reason why we think it wouldn't be an equilibrium when demand is not equal to supply is that there would be more people wanting something than is available of that thing. So there's like excess demand, and that will tend to drive up prices, right? But in this economy, there's both excess and insufficient demand at the same time, right? Things are on every side of the amount that's available, right? And so there's not going to be any systematic pressure on prices in any direction. So what this basically tells us is that large numbers of people, or even uncertainty, or differences among people, fill in the gaps and make sure that equilibrium exists. And thus, in most realistic settings, where we'd actually want to think about equilibrium, equilibrium does exist. And this is not just true in general equilibrium, which we're talking about right now, but also in some of the things we'll talk about when we do oligopoly, like game theory. In almost every context, equilibrium exists as long as you take into account the realistic nature of the situation, that there's uncertainty, there's heterogeneity, and there's a large number of people. So if you are coming across a model that doesn't have an equilibrium, it's probably because you're leaving out one of those realistic features. And this is particularly true in general equilibrium, because if there were a small number of people, then you wouldn't be acting like a price taker, right? And so the thing that we know always solves the problem, having a large number of people, is also sort of a necessary assumption for the theory to make sense in the first place. So if it's a real issue that there's a small number of people, you should think about an oligopoly or a monopoly model where an equilibrium would exist in that context. So the basic point is that if equilibrium fails to exist, this is an indication to you that you've missed some realistic feature of the situation, and that's what's causing the problem for you. In that sense, non-existence isn't a real problem in the world, it's a problem with your model. And in the absolute worst case, you can just change your notion of equilibrium, so you can use something like this notion of approximate equilibrium rather than exact equilibrium. So the overall point is never be a slave to your definitions and the formalism, and don't just say, oh, equilibrium doesn't exist, or come to some sort of like nonsensical conclusion just because that's what your model tells you. Change the model. Don't reach a stupid conclusion, right? That's the basic point of this. Okay. So, now we want to start thinking about what production adds to the gains from trade. And is Abigail here? No. God, we're losing people. Okay. So, who else wants to take it? Bill, do you want to?
Sure.
Yeah.
Just sort of what I was saying earlier,
Yeah.
with trade allows different companies or whatever to specialize in what they have a comparative advantage in, and everyone's better out.
Yeah, that's exactly right. So, just to give an example of that, Brazil is really good at growing sugar, right? So imagine it costs one computer. That Brazil can, for each computer that it makes, it could instead make a ton of sugar. And China, on the other hand, is much better at building computers. So it costs them only 1/10 of a ton of sugar in order to make a computer, right? So on this basis, we say that China has a comparative advantage in making computers, and Brazil has a comparative advantage in growing sugar. Even if China can produce both more cheaply, yeah.
That's what I was going to ask.
Yeah, so imagine that China can produce both more cheaply in dollars, but that the amount of sugar they have to give up to make a computer, or is smaller. In other words, the number of computers they'd have to give up to make a ton of sugar is greater, right? So even if China has an absolute advantage, which isn't really true, but even if they were better at growing sugar than Brazil, if they have this comparative advantage in making in making computers, then they're going to want to specialize in that. And the reason is that, China could produce 100 computers, and Brazil, so imagine China is much more productive. So if China can produce 100 computers, or 10 tons of sugar, right? So they're more productive overall, right? Brazil can produce 8 tons of sugar or 8 computers, so they're much less productive. But if Brazil focuses on producing sugar and China focuses on producing computers, they could create 80 computers and 10 tons of sugar, which could never be produced by any of the countries doing it on their own, because at most, if China tried to produce, things in a proportion 8/10, right? China would only produce 50 computers and 5 tons of sugar. And if Brazil tried to do the same thing, they would produce 7 computers and 1 ton of sugar. And you add those two things together, and it's a heck of a lot less than 80 computers and 10 tons of sugar, right? It's 57 computers and 6 tons of sugar. And the reason is that Brazil is just more productive, so it doesn't make sense for Brazil to be making any computers, and it doesn't make sense for China to be making any sugar. They should specialize, and then they should sort of determine between them what the right mixture is. So this is very analogous, actually, to just what was going on in the exchange economy, right? Because you who like candy and I who like foie gras I can make a lot more utility out of foie gras, and you can make a lot more utility out of candy. So I should specialize in eating the foie gras, and you should specialize in eating the candy. And so if I start with the candy and you start with the foie gras, we should trade, and we'll both be better off, right? This is just the opposite of that for production. Rather than everyone consuming what they enjoy most, everyone produces what they're best at producing, right? Okay, Emily, do you want to draw a picture of this? Come up here. Press hard and I'll hold it back instead of pressing. Maybe like they're like production possibilities frontiers, and then show how they change.
So maybe we could have.
Yes.
So maybe we could have a Brazilian production possibilities frontier, something like that.
Yeah.
And a Chinese one that is something like that.
Except they're going to be bigger to hit an absolute advantage. That's fine. Yeah.
And together they would be something like that.
Yeah, but it's actually going to be kinked, right? Because you're going to switch at some point from one production to the other, right? So it'll be like that, right? But the thing is, that's much better than what they can get on their own, because they'd be going at the same rate of substitution for each one of them, right? And so they do much better taking advantage of the superior efficiency until they have to take advantage of the inferior efficiency. Right? Yeah, great. Okay. Now, while trade is beneficial to a society overall, it's not necessarily beneficial to every individual person within a society. So if there are imagine there's two different groups, there's farmers who own the farms and factory owners who own the factories, or workers in the factories who work in the factories. Now overall, if the two countries trade with one another, imagine one is better at agriculture and the other is better at manufacturing, then overall the societies will benefit by one country specializing in farming and the other specializing in manufacturing. So China should specialize in manufacturing the computers, Brazil should specialize in manufacturing the sugar, growing the sugar. So prices, rather than before, right, it took one computer in China to make 10 tons, one computer to make 1/10 of a ton, and so the price of a computer in terms of sugar was 10, right? Was 1/10. And in Brazil, it was 1 for 1, right? Now you might think that once they're trading with one another, the prices are going to have to be the same, because otherwise you'll export across the country. So the price is going to come to be somewhere in between the two of them. 5 computers per ton of sugar, maybe, right? So then the price that the Chinese farmers are getting for their sugar is half what they used to be getting for it, right? And on the other hand, a Brazilian factory owner is now getting 1/5 as much for his computers as he was getting before.